Welcome everyone to Math Time. I'm Mr. Julius Sineta, or you can call me Boss G, and I will be your teacher for today's lesson. Good day everyone. For today's lesson, we will be tackling illustrating linear equations in two variables. Linear equation with one unknown was first introduced to you in your previous grade level. These equations contain only a single variable, usually an x. So you learn how to determine the value of the unknown as well as to solve for the value of the equations. But for now, we will be dealing with linear equations in two variables. What are these linear equations in two variables? So when we say linear equation in two variables, it is an equation that can be written as ax plus a by is equal to c, where a, b, and c are real numbers and a is not equal to 0. The numbers a, b are called the numerical coefficients of the equation, and the number c is called the constant of the equation. Okay, here are examples of linear equations in two variables. X plus 4y is equal to 11. 3x minus 4y is equal to 11. 2x is equal to y. X minus 7y is equal to 0. So aside from the examples that I have given you, there are many other ways of writing linear equations in two variables. So we can have y is equal to 2x minus 4. Y minus 2 is equal to 3 multiplied by the quantity x plus 1. 2x plus 3y plus 5 is equal to 0. And x plus y is equal to 9. Take note that not all given equations are considered as linear equations. Say for example, we have here 2x squared plus y squared is equal to 18. That is not a linear equation. Same as true with square root of x minus 1 is equal to 4. That is not also a linear equation. Now going back to the first one, why is it that it is not considered as a linear equation? Okay? The variables like x and y in linear equation do not have exponents other than 1. So as you can see on the given equation, the exponent is 2. So therefore, that is not a linear equation in two variables. How about the second one? Square root of x minus y is equal to 4. Why is it that this is not a linear equation? That is because the presence of square roots, cube roots, and the like is seen on the given equation. Therefore, it is not a linear equation in two variables. Going back to our last 4 examples, we have there y is equal to 2x minus 4, y minus 2 is equal to 3 multiplied by x plus 1, 2x plus 3y plus 5 is equal to 0, x plus y is equal to 9. If you notice, they are written in different forms. Yes, you're right. They are actually written in different forms. For y is equal to 2x minus 4, it is written in slope intercept form. For y minus 2 is equal to 3 multiplied by the quantity x plus 1, it is written in point slope form. 2x plus 3y plus 5 is equal to 0 is written in the general form, while x plus y is equal to 9 is written in standard form. So there are different kinds of form wherein you can write linear equations into variables. But remember this, you can actually convert or change a linear equation in two variables written in slope-intercept form and transform it into a general form. Same as true with standard form, you can transform it as slope-intercept form, or you can have a slope-intercept form transform it to point-slope form and vice versa. So what we're going to do next is to change or to transform or to write a linear equation in two variables written in a certain form and transform it into another form, or we can rewrite it into another form. For us to transform a linear equation in two variables from one form to another, of course, we need to have a background about the different forms of writing linear equations in two variables. The most common form of linear equation in two variables is the slope-intercept form of the equation. We follow the form y is equal to mx plus b, wherein m here is the slope and b is y-intercept. So here are examples of linear equations in two variables written in slope-intercept form. We have y is equal to 2x plus 1. M here, or the slope, is equal to 2, and the b, or the y-intercept, is equal to 1. So another, we have here y is equal to negative 5x plus 3. The slope is equal to negative 5 and y-intercept is 3. Another, we have y is equal to 4x. The slope is equal to 4 and y-intercept is equal to 0. Another form wherein you can use to write a linear equations in two variables is the point slope form. In point slope form equation of the line, we use the form y minus y sum 1 is equal to m multiplied by x minus x sub 1. Of course, your m here is the slope. So here are examples of linear equations in two variables written in point slope form. So y minus 3 is equal to 2 multiplied by x minus 1. We also have here y minus 4 is equal to 1/2 multiplied by x plus 2. And there is also the general form of the linear equation in two variables. So we follow the form ax plus by plus c is equal to 0, where a, b, and c are all real numbers and a and b cannot be both equal to 0. Say for example, we have here number 1, 3x plus 2y minus 4 is equal to 0. A here is equal to 3, b is equal to 2, and c is equal to negative 4. So another one, we have here x minus 4y plus 6 is equal to 0. A is equal to 1, B is equal to negative 4, and C is equal to positive 6. And lastly, we also have here the standard form. So in standard form, we follow the form ax plus by is equal to c, wherein a and b and c are real numbers and that a and b should not be both equal to 0. So here are examples of linear equations in two variables written in standard forms. We have here x plus 3y is equal to 7. Negative 4x plus 5y is equal to negative 9. As I said a while ago, a linear equation in two variables may be transformed in other forms without changing its actual value. So you can transform a linear equation in two variables written in slope-intercept form into a general form, or general form transform it into point-slope form, or a point-slope form transform it into a slope-intercept form. Okay, let's try some examples. Let's say we have here 2x plus y is equal to 6. Now let's change it into slope-intercept form. Okay, how are we going to do that? Say we have here 2x plus y is equal to 6. We need to follow the form y is equal to mx plus b. So we need to transpose 2x to the other side of the equation. So we now have here y is equal to 6 minus 2x. Now following this form, y is equal to negative 2x plus 6. And you now have transformed a linear equation written in standard form into slope-intercept form. Okay, let's try one more. Let's say we have here y is equal to x over 2 minus 5. So we need to transform this in general form. As you can see, the given linear equation in two variables is written in slope-intercept form. Now we are going to transform it or change the equation into general form. So we take the given y is equal to x over 2 minus 5. So for us to remove or eradicate the denominator 2, we need to multiply the whole equation by 2. So 2 times y, that is 2y equal to, so 2 multiplied by x over 2 is x minus 10. Okay? So since the general form follows the form ax plus by plus c is equal to 0. So we need to transpose x to the other side of the equation and negative 10 to the other side of the equation. So if we transpose x to the other side of the equation, from positive it becomes negative, and negative 10 when transposed to the other side of the equation, it becomes positive. So negative x plus 2y plus 10 is equal to 0. And you now have transformed or changed the equation written in slope-intercept form into general form. Okay, let's try some more. Let's have number 3. Say we have here 2x plus 3y, 2x plus 3y minus 18 equals 0. Transform it into slope intercept form. If you notice, the given linear equation in two variables is written in general form. So how are we going to do that? Remember, the slope-intercept form follows the form y is equal to mx plus b. So 2x plus 3y minus 18 equals 0. We need to transpose positive 2x to the other side of the equation. Same as true with negative 18 to the other side of the equation. So from positive 2x, transposing it to the other side, it becomes negative 2x. Negative 18 transposed to the other side becomes positive 18. And you have here 3, 1. Now take note, it says here y. Now how are we going to remove the coefficient of y here? So we need to divide both sides of the equation by 3. So cancel, y is equal to negative 2x over 3 plus 18 over 3. Y is equal to negative 2/3 x plus 18 over 3 is equal to 6. And you now have transformed the given linear equation in two variables from general form to slope-intercept form. Thank you for watching. I hope you learned something from me today.